Hello, Jack here again, and just wanted to go over. We've got these eCogs here that I just talked about, but one of the neat things about these eCogs are it really demonstrates how it's going to work, where you can connect four different eCogs, and you can easily manage so that there's no conflicts between pins. So, and the way that that works is you're going to use these dots that are on the eCogs, dots, squares, and triangles, to make sure that you're not conflicting and stepping on other eCogs. So if we go and we look at the GadgetBox board, and we look at the legend, we see that we've got four quadrants. We've got AL, AH, BL, BH, and we've got it marked on the silk screen that we've got circles, and circles are digital I/O. Triangles are analog pins, and squares are PWM pins. So if we go back and we look, we look at the button and LED eCog, we see that it uses four GPIO pins, and this will line up. So we're putting this in the AH quadrant, and so we should see that there's 1, 2, 3, 4 circles. So the circles line up, and we could see that no other eCog is using those four pins. So now when we go to the remote control eCog, we're seeing that we're using four pins. Two of those pins are digital I/O, and two of those pins are PWMs. But we see of these 8 pins here, there's no conflict, because 4 pins are using the LED, and then the remote control one are using the other 4 pins. And so now if we go back and we look at the legend, we see that for BL, 2 circles, that matches, and then we've got 2 squares. So we should have the functions correct. Now for the Wi-Fi, we see that we need 4 digital I/O pins, and we've got a blank eCog here, so it's not actually using any pins, so there's definitely no conflict there. Okay, and if we want to, we could look here. We see there's no conflicts because we've got a Wi-Fi pin using 4 digital I/O. We've got a sensor pin that's using 2 analog, and then the SD card uses SPI, so it doesn't use any of the general purpose I/O, and the display is using I2C. So once again, both of these have their own bus connections. And then let's look at this guy, and it's kind of a similar situation. The display uses a bus, Wi-Fi uses 4 digital I/O, the joystick pin uses 2 analog, and then the button LEDs using 4 digital I/O. So you could see, it's kind of an interesting scheme that allows you to prevent conflicts and also easily match up functions.